equations for friction. They look almost the same, but it depends on the type of friction you're dealing with. Okay, so the equations for kinetic friction is the kinetic friction force equals mu sub k for kinetic friction times the normal force. Fn is the normal force between the surfaces. The normal force is caused by the very same intermolecular bonding that also causes friction. So the greater normal force you have equals the greater frictional force there will be. Mu k is called the coefficient of kinetic friction. This number depends on what the object and surface are both made of. Ice has a low coefficient of kinetic friction, while rubber has a high coefficient of kinetic friction. The value of mu sub k can be between 0 and 1 and has no units. If we solve this equation for mu sub k, then we would divide out Fn from each side, and we would get mu k equals the force of friction over the normal force. The inequality for static friction is static friction is less than or equal to the coefficient of friction times the normal force. Wait a minute. Inequality. The equation for static friction is F sub F is less than the coefficient for static friction times your normal force, where F sub n is again the normal force between the surfaces, mu sub s is the coefficient of static friction. Again, it depends on what the object and surface are both made of. It's between 0 and 1 and has no units. For a specific pair of materials, mu s is always greater than mu k because static friction is stronger than kinetic friction. So 0 is less than mu k, which is less than static friction, which is less than 1. Enough of that talking. Explain me the deal. All right. So here's the deal. If an object is not sliding, then static friction will only be just enough to cancel out any applied force that is trying to make the sliding begin. If the applied force is stronger than static friction's maximum, static friction breaks, and the object begins to slide, and weaker kinetic friction takes over. We're going to see this on the next few slides. Animation of it to make it make sense, because cartoons always help. So here we go. In this animation, we see a spring pulling on a box. As the spring stretches more, its rightward force on the box increases. Spring force, frictional force. There's a backward frictional force, this one that's growing, as we're pulling more and more, which changes from static to kinetic during the course of the animation. Once it hits a certain number, then it switches down to 40 newtons. The mass of the box is 10 kilograms, so its weight is 100 newtons. That makes the normal force 100 newtons to cancel the downward weight force. In this animation, the coefficients of friction are mu sub s equals 0.6 and mu sub k equals 0.4. This makes the kinetic friction, mu sub k times Fn, 0.4 times 100, 40 newtons. What about static friction? In the equation F sub F is less than or equal to mu s times Fn, we can calculate mu s times Fn, 0.6 times 100 equals 60 newtons. What does this mean? It means that static friction can be at most 60 newtons. Now watch the animation. As the spring force increases, the static friction increases to balance to prevent the box from sliding. And then once our spring force gets greater than 60, at the instant the spring force is 60 newtons, the maximum strength that the static friction can be, the equation in the upper right-hand corner of the animation changes from less than to equal, and changes from red to yellow in that instant. Here it comes. Ready, now. That's a lot to watch. These numbers on the left, and then the numbers over here. But when the spring force becomes greater than 60 newtons, or the static friction's maximum, static friction breaks, the box begins to slide, and the weaker kinetic friction takes over, and the equation becomes green. Because kinetic friction acts to make sliding quit, kinetic friction is always maxed out at 40 newtons. The equation for friction is on the AP Physics equation sheet. I know it looks different. The equation doesn't show the difference between static and kinetic friction and only relates magnitudes. Notice the absolute values, not directions. Okay, so the directions is all on you. The magnitude of your frictional force is less than or equal to coefficient of friction times the magnitude of your normal force. Less than or equal to. Can be equal to if we're dealing with kinetic friction, or it can be less than for static friction.